Hello, everyone. Can you hear me?
Yes.
Thank you. Thank you.
Yes.
Thank you so much. So today we are going to learn hypothesis testing, how it starts, what is the process we are going to learn. So basically, you can have hypothesis based on different things. One is about mean. One is about standard deviation or variance. One is about proportion. So you can formulate the hypothesis and you can test your hypothesis and you can make your conclusion. So let's say we are going to start a hypothesis and we are going to prove that and just learn how we do it. So just a minute. The hypothesis is that you don't share your real number. Let's see. I'm making assumption we have 13 students in our class as of now, real life. And my simple assumption is average age or salary. I'm just average salary of students in my class is 90,000. How much US dollar? 90,000. This is my assumption. I don't know your salary and nothing. And okay, so so I have to see the null hypothesis and I have to see the alternative hypothesis. So this is my assumption. And we are talking and you said, I don't think it is 90,000. It will be more. Okay, then, okay, let's test this. So this is my hypothesis. This is my assumption. Now, based on that, I make a null hypothesis. Null hypothesis is written like H0. It is Y0, hypothesis 0. 0 means no difference. 0 mean null means no difference between my assumption and actually from practical. So H0 equal to mu equal to 90,000, 90K. Then I have to write alternative hypothesis also. Mu not equal to 90K. So first step, make your assumption or hypothesis, write null hypothesis, alternatives hypothesis, then decision rule. So decision rule alpha at 5% level, alpha is 0.05, or in other words, we can say confidence interval, confidence level 95%. Okay, everyone is with me. What I'm trying to say, what I'm trying to do. Is it clear so far to everyone?
Yes.
Perfect. Thank you. Now, third step is to collect data. So I'm just salary and we have how many students? 13. I would request you to give any salary number, not real, any number that you feel is good from your side. Any number, just keep putting in chat so I can start putting right here. Okay, 75. Just a minute, one by one. So first is 75. Second is 55. Third is 75. And so 3. 4 is 100,000. And what about 95? 160. 95,000. 160,000. Everyone just share just one number, salary number. Okay, 7285. 85,000. 72, 85, then 325. If somebody is earning 325, no need to do MBA. You are better off. Excel in your field. 130, 325, then 87. More is the sample size, better result you will achieve. So, you remember, keep more and more sample size and you will get better results. So I think I got how many? 11 of them. Okay, fine. We are going to work with 11 data point. We have, if I get two more from two more students, if I miss something, you can share some number. If no, no problem. Okay, so this is our salary. And now I'm going to check whether I'm correct or wrong. So I go under statistics, basic statistics, one sample t-test. Why I'm doing T or Z or two pair, I mean, these are the options. Why I'm using T, I will let you know. Okay. Here is and then summarized. You can see one or more sample in each column. So I have sample here. Hypothesis test, I have 90,000. Did I say 90,000? That's correct. I have option under 95,000, and this is my mean equal to hypothesized mean. And graph, I can do, different thing. I don't, and this is the option. So this is the option. In other words, if I have, if I get the summary of these 10 or 11 sample, I can do also. So, there's another way to do statistics, basic statistics. Oh, sorry, statistics, basic statistics, and let me see. And I need a mean and standard deviation. And so I need mean, I need standard. Where is standard deviation? Yeah, this is okay. So okay, I have to do descriptive. So this is a mean, this is a standard deviation of the data I have. Now I do this. So basic statistics, one sample t-test. So I can summarize data. Sample size is 11. Mean is 116,237. Standard deviation is 76,348. And we are going to perform hypothesis. So if you have summarized data, like the mean and other things, or you have directly data from, you want to do from, directly, you can do either way. So we are directly taking from the column. Hypothesized value is 90,000. Okay. Option, you can change the confidence interval, and now you do okay. And now, so what are the steps so far we did? We made assumption, we did null and alternative hypothesis, we did significance level, we decided 5%. Now we collected the data, and now after collecting data, we did the calculation. This is a calculation. This is the calculation. And now we are going to do this. So now we are going to make decision. So calculation is T value is here, P value is here. This is null hypothesis. This is alternative hypothesis. So you can see mu equal to 90,000. Alternative automatically not 90,000. Now, based on the data that we have and based on the calculation, what we get, this is a 95% confidence. This is mean. Means you are able to see everything. Now look into that. What null hypothesis says, mu equal to 9. When null hypothesis can be proved? In this condition. So just, you look into. So, oh, sorry. Can you see this? And so for
yes,
mu,
we can.
yeah, so this is a 64,981. And this is 167. 167,564, whatever number you can say. This is your confidence interval. This is lower, this is upper. Means within this, all the values will come. Or t value we got 1.14 and p value we got 2.80. So let me do one more thing and then you can decide. So statistics, graph, and we go probability distribution and look into that, view probability, and we are going to do t distribution and degree of what is the degree of freedom? We have sample 11, so degree of freedom would be
10.
10.
yes. And then we have to see the 95, which is right here. We have to see these two-sided thing because we are checking, and then you can see. So now you have the result, you have the, these things, and now we are going to make our decision. So let me remove this writing part. Okay. Here we are. Okay, I think you can. Okay, now you have. So t value is 1.14. Here you see t.1.14, where it will come. So basically this is 0. The t value is coming somewhere here, 1.14. So our null hypothesis says there is no difference in my assumption and all the students' salary. Alternative says there is a difference in your assumption and alternative salary. Now what you draw the conclusion. So this is a table value. Our value is coming within this. Means what we can say, this is a t value, this is a p value, and this is the table value. Any idea that you can think? Which hypothesis is correct? Which statement is correct?
We would accept it.
Which?
Accept the mean hypothesis, null hypothesis.
Very good. Very good. That's excellent answer. Null hypothesis is correct. That means my assumption, average age of all MBA students, those who are doing in Eastern Washington, their salary is 90,000. All the students, those sample is only 11 students. But this sample is small, so basically normally when we really do a practical, we need to have sufficient sample. We are doing this experiment. So look into this. So alternative is automatically rejected. Null, we say it's correct. Null hypothesis, that means all students' salary would be 90,000 with 5% still chances it may not be 90. We are confident that 95% all students' salary will be. Are you understanding what I'm trying to say? Is it making sense to everyone? Perfect. So we got, this null. There's another rule that you must remember. And so basically we are not going to use this t value, t value for you to understand, but we are going to use p value in order to accept or reject the hypothesis. And we are going to use in this course and next course. And it is always valuable to use the t value, a p value, because you always get, and this is a rule of thumb you keep in mind from the statistics. If alpha value, what is alpha value? Okay, if p value is greater than alpha value, then what happens? H0 is correct. H0 is true. Or we fail to reject null hypothesis. I'm simply, in simple word, H0 is correct. Remember. Oh, sorry, I'm just a p value.
So if we're interpreting this right, if the p-value of 0.28 is larger than the alpha value of 0.05, then
Yes.
the null hypothesis is correct.
Exactly, always. in this course
Okay.
and next course. If p value is less than alpha value, then
Okay.
H1 is correct, or alternative H1 or AHA is correct. So this you keep in mind, because we are going to use straightforward this rule based on that. And there's also, reason. So why p value, because this hypothesis is able to, okay, I can explain this just a minute, why we are using this principle. So look into this. So P is 28%, means probability of this is happening. So 14% here and 14% here. This hypothesis is, is accepted in this point 14 and 0.14. This is why we need, we are just trying to check on 95, which is 2.5 this side, or 2.5%, I can write this way, 2.5. If it is able to, accepted in 14% this side or 14% this side, means 20, how much? 28 means if it is getting accepted in 72%, why we are using 95? So basically, p value plays a vital role. So if p value is lost, means this hypothesis is proved in within 72% of confidence interval. This is 70. Why we are using 95? Is it making sense? Why we use that thumb rule?
Is it because you're saying that the 72% will always fall within the 95%
Yeah, exactly.
range? And so when you take the p value divided by 2, it's less than the alpha value divided by 2. So the
Yes.
14% is less than, so it always falls within that 95% confidence level.
Yes, always within that. Correct.
Okay, that makes sense.
Yeah, so this is the rule always. If probability p value, so null hypothesis accepted. And so I hope you understand what I'm trying to. So this is now. So I say the average student's salary of all MBA is 90. I'm correct with this sample, with this statistics practical. Is it making sense? So this is the practical. Now, if you do the real practical related to anything, now we have different condition, different rules that we need to understand. So let me open some real data and let me show some work. So just a minute. We have, similar way, we have three other things. Now we are comparing the mean. We can also compare. What we can compare? We can compare proportion or pi. We can compare sigma, which is standard deviation. We can compare variance. So these things we can also compare. Is it making sense? Means what we can compare? The proportion, let's say male, female students in my MBA. I say 50%, 56% students are female. Okay, this is my assumption based on the sample. I mean, I don't want to go here, but if I say, so let's say I say, okay, pi, null hypothesis is pi equal to 0.56. Okay. Alternative again says pi not equal to 0.56. Okay, this is, like null alternative, again significance alpha equal to 5%. And then I ask all of you, and you can give, okay, your, I write the gender here. So let's say gender, and I can write again same. Let's say 1 for female, 0 for male, and I keep going for 13 observation. And then I can go for statistics and I can do where is one proportion. This is one proportion, and I can, use this perform hypothesis. I can do 0.56 and option 95%. Now here methods are approximately exact. What is the approximate and what is, you remember the binomial distribution when, normal approximation n pi equal to point, what is the n pi equal to or greater than 10 and 1 minus pi equal to greater than equal to 10. If you remember that condition, check that condition, then you can approximate. Is it making sense? And you can do that. And you can also get the t-value. Since I have only two numbers, I am not going to do. But yeah, that is the way. Is it making sense when we use the, or you can do the number of events, number of tries? Is it making sense? When do we use the proportion test, proportion hypothesis? Okay, the third option is basic statistics, one sample z-test. So here this is when you know the, if you remember the last chapter, when you know the population standard deviation, then you can use this. So let's say I'm just going to do, okay, this is a salary. And okay, standard deviation is given 50,000. What is the standard deviation of all the population, all the student is 50,000. So I go statistics, basic statistics, the same thing I'm applying here, one sample Z, and I use the salary here. It is given the standard deviation of all student salary is 50,000. So I'm just going to put 50,000, perform hypothesis testing, 90,000. And then, so basically this is the difference between t-test and z-test. Like you remember last lecture, when do we use z, when do we use t? So this is the only difference. Now I go here and I hope it is 95, yes. Okay. What do you suggest? What do you suggest? What is the... So this is a z statistics and this is value. So what do you say?
Null is true.
Null is true means still, if 50,000 is the standard deviation of all the students' salary, still, the statement is true. And you can see the z value, you can see the p value is 8%, alpha value is 5%, and z value, we can draw the graph here, right? Probability distribution. And we can say if it falls under this, so I go under z distribution, normal distribution. Normal, and mean is always 0. And let's say we want to do this 5%. So minus plus minus 1.96, it should be the value, then null hypothesis is accepted. So here it is within minus 1.96 to plus 1.96. So these are the three cases that we have in this chapter. Now we come to the another situation. Now you say what you say, the salary is more than 90,000. Null hypothesis can be like, now we are saying is 90,000. I say null hypothesis says mu equal to greater than or equal to 90,000. H0, H1 says, this is, new case, mu is less than equal to, less than. So, opposite of this, not equal sign, 90K. Now we have this and we are going to, so we just change the assumption that I say the salary is more than 90,000 of all my, all MBA students. Let's say Let's check this. So I go under statistics, basic statistics. Again, I'm going to use the t-test. And okay. Oh, sorry. So I think I did something. Okay, here you see the salary. And now we go to option. Here you have all alternative. What is the alternative? So you have confidence, you can select. So this is equal, not equal to, you have less, you have mean is greater than hypothesized mean. What is the, I'm saying it is more than 90,000, means mean is more than 90,000. Okay, that's it. I selected. Now you can see. What do you suggest? What is your understanding?
Null is true.
Null is true. And null says, oh, sorry, this is basically I selected, this is null is true. So we have to select alternative option in order to get. So basically null is saying here, I think I did. Null is saying less than or equal to 90,000 and alternative is saying more than. So basically this is a selection is opposite. So there is a one sample t-test. Here, please. Okay, I mean, this is alternative. So alternative says mean is low. I mean, this. So basically we decided that salary is more than 90,000. So we have to select the null hypothesis, alternative hypothesis. It is not giving the null hypothesis. So we have selected this is the correct hypothesis. Now we say and we decide. So we are correct. So null hypothesis is still holds good because it is p-value is more than. Now let's say somebody is saying alternative is great. So
Why wouldn't they show greater than on the null hypothesis?
oh, so actually this is a mini tab. These are the, if you look into the book, or I can open the slide, slides. Just a minute. So book, mini tab has some other things. So automatically you understand. So just a minute. So this is H1, 2, and then we come to the T calculator, and then you have the right tail or left tail test. And yeah, this is the rule that you need to follow in order to assume normality. So here, you can see they say, so proportion is this, not equal to. Here you can see less than. So automatically, because that is a boundary condition, you can always look into equal to or less than, and then second is opposite.
Got it.
So
Yeah,
on
go ahead.
on that, what I'm seeing, if I'm reading that correctly, is whatever's not included in the in the opposite, not what's the term for the non-null hypothesis, is included. So if it says it's less than, then the null hypothesis includes greater than and equal to.
Yeah, so you can see this is the slide, mu is less than or equal to 216 mm. Alternative says only one sign, which is greater than or less than. But, this includes, this include, you can see this part. So is it making sense? You have to, Minitab has this limitation. They don't put both sign, but we have to understand. So, and their hypothesis is based, their option is only based on this part. Alternative hypothesis, they don't have. So automatically, if you select like mu is greater than, then automatically you understand this is a null hypothesis. If they select less than, automatically you understand this is greater than or equal to.
That makes sense.
So this is right side. This is so basically these are the options. So if you say I think the third one, which is basic one sample T, and we have to see. Now we did this thing. Now we are going to do the last one. And what is the meaning is they are saying it is saying less than or equal. So alternative is saying mu equal to 90,000. I mean, mu is greater than 90,000. And it is saying null is saying less than 90,000. What is your interpretation? Because T value remains same.
Null hypothesis is still true.
Is still true, and alternative is, and this is happening because we have very limited data and few values are highly scattered. You can see this value, probably this or that. So if I remove these 2-3 numbers, you can see or instead of that, I can put 88,000 because this is highly skewed. Which one is? I think 325 is highly skewed. So something like 125,000 I can put instead of. So we have to see before going into decision making, we have to look into the data also. 101,000, and let's do the same experiment. Statistics, basic. And now, and what we are doing, mean is, so alternative is saying mean is greater than. Okay, now what do you see? Average is saying, so basically mu equal to, still the null hypothesis is proved. But when you do the real big numbers like more than 30, then only you can approximate and you can go. So always, if you need to get a good results, always have the bigger sample size. Is it making sense? Everyone?
Yes.
If you have, any, I think this is what is about this chapter. I think, yeah, this is what is about chapter. Yeah. 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 One more thing that I just missed, So here says about the standard deviation or this. So I just take this. I go in statistics, and this is basic and one variance, or one standard deviation and variance. You know the difference between them. Sample standard, sample variance in each column. So I go in sample, perform hypothesis test. Okay, I say 50,000 is the standard deviation, or standard deviation. What? Okay, I just give the 50,000, and the standard deviation, all the student salary would be 50,000. This is my hypothesis. Option the same way. Here, instead of T and this, we use chi-square. So you can see here is a chi-square degree of freedom. Probability is this. And what is the probability? Sigma equal to 50,000, sigma not equal to 50,000. And what you can assume from chi-square. So this is saying sigma is not equal to 50,000. What is the value that has been probed? Because p value is less than sigma value, is less than alpha value, sorry. P value is less than alpha value. So we conclude null hypothesis is not correct. Alternative hypothesis is correct. There are two methods. One is Bonnet, another is chi-square. So is it making sense to you?
Yeah, the method of evaluation using alpha makes sense.
Okay. Yeah, so even you can do the test statistics with chi-square. Here we have the two options. When do we select Bonnet, and chi-square is the usual. So you can go under graph, you can go probability distribution, you can go under view probability. And here we have to select the chi-square. Chi-square degree of freedom, we have 10. And again, the shaded area is 5%. And okay, here we go. The value should be between 3.241 to 20.48 in order to be confidence, in order to be null hypothesis to be proved. What is the value that we got for chi-square is 1.37. 1.37 is falling in the red zone. Is it coming in the red side? I mean, left side in the red zone. And
Yes.
therefore, null hypothesis is rejected. Alternative is accepted. So this is the lesson of this week. Any question, any comment, feel free to ask.
Most of the questions are based around it looks like a known mean and then a target mean.
Exactly.
Is that where we're putting the alternative hypothesis in effect, or that's when we're trying to determine?
Yeah.
So okay.
Yeah, so here, this is one sample hypothesis. We are just using like you want to see your salary is let's say you see and you collect the data. So this is only one sample. We are not using two sample. When we use two sample, we compare and we do this. So this is one, but you have to compare this sample with some benchmarked value, isn't it? So you benchmarked, or like I said, 90,000, you benchmark, anything like your product, let's say your product weight, you are doing an inspection of the product that you are manufacturing. Weight is like 100 gram. 100 gram is the product weight, and you are measuring, you are taking a sample of 30 products randomly in production line. And you are saying, okay, one is 81 gram, one is 79 gram, one is exceed. And you just, and then check, whether your quality is proper or not. You are seeing the house price in particular area. Let's say house price in your area is about mean average house price is $500,000. Then you need to check, you go on Zillow and find 10 houses, 30, 35 houses close to your high area, which are recently sold. Collect all those data and put it and compare with your assumption that, okay, 500,000 is a mean average sale price in your area. So basically, we are always comparing with some benchmarked or some standard or some assumed value. Is it making sense in one hypothesis testing?
Yeah. I think it's deciding how to set the alternative hypothesis up with that in mind.
Yeah. And you can say it is more than also my house prices in my area is more than 500,000. Less than 500,000 means you have all three permutation and combination. I just explaining one type. Okay. So if you don't have any question, I would like to say have a wonderful evening. Have a wonderful productive week ahead to all you people. And
I have one more question.
Yeah, please go
Sorry,
ahead.
hold on. We didn't really talk that much about the power curves and OC curves, and I didn't really understand that in the book.
Okay. Oh, sorry, I skipped. Okay, thank you. So there are two errors possible, error 1 and error 2. And we are not, this will make a little difficult. So let's say there's a power curve and, it is called error 1 and error 2. Let's say, here we go. So we are not covering in this, but I would like to make it simple. So therefore, this is the slide that you need to keep in mind. Sorry, I forgot. H0 is true and you are rejecting H0. Means it is true. Practical, it is true, but you are rejecting H0. That is called type 1 error, or it is also called alpha error. And H0 is false and you are rejecting H0, that's correct. H0 is false and you are making, that's correct decision. H0 is true and you are failed to reject H0 because this is, correct decision. But H0 is false and you are failed to reject, which is called beta error or type 2 error. Why these errors are possible? So I'm giving, in nutshell, in just brief, why these two types of error, and power curve is totally related to that. Okay. So here we go. Let's say, okay, we don't have correct data. Here, for example, let's say I made this hypothesis, the average is 90,000 for all of them. Okay, I mean, I made little wrong assumption. My data is showing it is 89,500 is the correct answer. So I make I make my assumption with 500 difference, like I increase this, and because of this slight wrong assumption, my hypothesis is failed. I mean, because we make assumption based on assumption, then we follow. So if this is due to a small difference, my hypothesis is failing. This is one type of error. The second thing of error, like, my hypothesis is like we made a 95% confidence. But if I increase my confidence level, my hypothesis is failed in 95% confidence. But it is just if I increase the confidence level 0.95 point, let's say 2, and my hypothesis is accepted, means I'm making here wrong confidence interval. If little change in confidence interval except giving the acceptance of my hypothesis, that is also. So basically these are the two reasons that alpha error and beta error can be possible. Your hypothesis is correct, but you are not accepting. So these are the two situations. Okay, so these are the two situations. H0 is true, but you are rejecting H0. H0 is false, but you are failed to reject H0 because of there's a confidence interval or something. Is it making sense? In brief, I just explained this. And then therefore we have power curve and other things in order to do this. And that is little complicated on the top of that, which I thought I skipped in brief. Am I able to answer your question? Who asked this question? I did not know, to be honest.
No, I did. It makes sense. Just the graphical representations they show in the book.
Yeah.
But
yeah, John, that is then that going into more detail. Yeah, this we have more time and like 15 weeks of learning this, then we could cover everything. Okay, if you don't have any other question, I would like to say wonderful evening and wonderful productive week ahead to all you people. Last thing, since 19th is the exam date, and would you like to cover the next class earlier this weekend so that you have more, because the assignment will be open on this Saturday. So would you like to meet me on Sunday? We can, yeah, so we can meet on Sunday, then you have entire time to do. Okay, then I will send the on Sunday evening about 6:30. Okay.
I have
Bye-bye.
a question about the final. Is it going to be, are we going to have like a practice exam that's available beforehand, or?
So basically the final exam that you are doing multiple choice question so far, like, all module you have done MCQ. So we are exam is only based on MCQ, no fill in the blank. You have multiple questions. Exactly whatever you are practicing, the questions will be similar. Okay.
All right. Perfect.
Will we have a chance to review those multiple choice quizzes at some point?
Oh, actually, the setting is like that. If I open, then the grading will be screwed. So you have the, when you start, and yeah, one more thing. it will be 2 hours for you to do the exam. But if you really understand the concept, you do, you can do in 30 minutes. So mostly questions are conceptual. I am telling again, conceptual means you have to have concept clear.
Okay, understood.
Okay.
And the test is one and done?
Yeah, one attempt only.
For the exam, are we downloading any like software or anything like that, or is it just like all the other quizzes we've had to have?
Exactly, it's a free. You can sit together, you can use book, you can use tables, you can use notes, you don't need to do. You are free to use all the resources and you can do the exam.
Okay, thank you.
You're
Is there
welcome.
going to be like a review for the exam next week by any chance?
Review means all the recordings are there. Whatever I'm teaching, that will be in exam. Yeah, I will not cover the next module. So basically, module number 1 to 5 will be in exam.
Okay, thank you.
You're welcome. Okay. Good night, everyone.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Thanks.
Thank you.
Everybody.
Bye.